Hello everyone. Hopefully I'm not too loud. My name is Eric. I was the team lead for the Mural Web Viewer project. I'm joined by my lovely development team, Chase, Rotch, and John, who also acted as our Scrum Master for this project. We were working with existing architecture by our client, the Mural app team, Patrick, John Baptiste, and Andy Grizzani, to give you a little bit of context as to what their service was and what we were building upon. I'll pass it up to Chase to give you a little intro.
Thank you, Eric. So to start, people love to share content online. This is no secret. All the way back in the early 2000s, we had MySpace, where people flocked to create their own personal corner of the internet and share YouTube links with their friends, etc., etc. Thank you. And then that has evolved to nowadays. Snapchat has the story feature, where you can upload pictures to your story, and for 24 hours they are available for everybody to see, as sort of like an update of what you're up to. Snapchat takes us a step further and actually plots public stories on the Snap map, which you can see up there. It acts as a heat map for other users to see areas of high Snapchat interactivity. Now, how this is important is it shows the sort of request for more location-based interactions with content, which is something that our client used heavily in their app, the Mvral app. So what Mvral is it's a platform for sharing location-bound content. Mvral, as opposed to the example of Snapchat, puts the emphasis on the location instead of the user. So it's not somebody's mural, it's a mural location. These locations have a set range from which they're allowed, you can interact with them. So you have to be within that range in order to upload content from your phone within the app, or to view content that has been previously uploaded. This is great, but this app has one small flaw, in that you need to be a registered user in order to use it. So there's very little way for new users to be exposed to what Mvral is. And yeah, so basically, our goal is to take the Mvral app and the existing architecture and to create a web application that will function similarly in a read-only mode. So there won't be any picture uploading, but users will be able to interact with content near them using their location. And, sorry. What was I saying? Yeah, upload, they won't be able to upload, but they'll be able to interact with content near them the same way they would in the app in any sort of read-only mode. So, as a quick terminology briefing, a mural or mural location is a virtual wall that users post images to. It does have a physical location though, and again, there's a radius drawn around that physical location that determines where users can interact with the app from, with the mural, I'm sorry. Typically, this range is from 50 to 500 meters, but it depends on what kind of mural it is. So a business may be a smaller mural, whereas an institution like UMass Dartmouth is a very large mural. And now we're going to disambiguate the types of users. So there's two main types of users. The typical users or viewers are people who are using the app to find out what Mvral is. They're probably going onto Mvral app. Sorry, let me slow down. They're probably on the Mvral web viewer, browsing content that is near them and viewing content. They also may simply be walking by a display of the Mvral web viewer that somebody else has set up for them. This person who set it up is most likely an owner of that display. So owners have the rights to change how their mural looks in that display. So owners are interested in seeing how their mural is doing, what content is there, and what does it look like on everybody's display. So to walk you through how a viewer who is using the app themselves would see the site, first we ask them for the location. We cannot allow them to use the app without giving the location permissions because, again, it's the idea of the app. You have to be within range of a mural to view any content. So we then show the viewer the in-range murals and some slightly out-of-range murals, just as the app would. And then we display the content in a grid form so that they can see all the sorts of content that is there before they enter a full-screen display, which will display new content as it arrives. For the owner, they would follow the same exact process up to their mural, and then once they're on their mural's full screen display, they can go to the top right corner and log in using the email and password for their account. A check is made to make sure that that account is the owner of the mural, and then once they successfully log in and they're validated to be the owner, they can personalize the full screen display for everybody who views it. The personalization includes things like how many images are on screen at a time, and how fast the images go, and what sort of display mode the images are displayed with. So now we are going to move straight into our demo.
I have no idea. It is up. Hey! Hello? Perfect. Okay. Sorry about that. You'd think a computer scientist would know how to use a microphone. So when you first enter the Mvral web viewer, you are asked to grant access to your location. Your browser just holds in your latitude and longitude. So we have the displays extended, so I think Chase needs to kind of get the... I didn't really think this part of the demo through. It's on a separate screen. Yeah, can you just move the mouse over? Hey, all right. So when you click grant access, the browser first requests your permission. If you block permission, you're not allowed to see the screen. So here we've set up a UMass Dartmouth mural. Unfortunately, we're not connected to the live database that the app is. We're still using our dev connection. So just keep that in mind as we go through our demo. But as you can see, there are the UMass Dartmouth item on the sidebar is lit up, and you can hover over it and see the radius of connectivity. We are well within range to view this content. But you can also see that like the New Bedford Airport and the Dartmouth Mall are also nearby but not connectable. This is to promote people to go around and look at other murals, and the map graciously shows you where that is. So when we click on a mural, it shows you all of the content that has been uploaded to it. This is not affected by the display properties in the database, and we'll get into why that's a little bit important in a second. So we'll click on View in Full Screen, and we have a carousel view of all of the content of the display. Right now, it's only showing a small subset of all of the images that you just saw on the gallery grid. And you can imagine in a city like New York City or Los Angeles, where there's a lot of traffic, there will be a lot of content to cycle through, and it would be unfair to the users who are posting content to wait 5 or 10 minutes for all of the content to slide through to see their post. So we're only showing a subset of these images. We can, this updates in real time. As I mentioned before, dev database, so we have a small little API route on a second screen that will upload a picture that the team took earlier. This will upload it to our database, and the carousel will update in real time with the new post. Look at us hanging out just about an hour ago. So if we wanted to show more content on this mural, we can move our mouse up to the top of the screen where 2 interaction buttons will pop down. The one on the left just brings you back to the map view in case you're in range of multiple murals and want to view a different one. But the one on the right is what we're more interested in, and this allows us to log in and edit the mural. So in here, we are using an authentication system called Firebase Auth. We'll get into that a little bit. And we check for user credentials, and then also we do an ownership check, because there could be many valid credentials, but only one set of credentials is valid for a particular mural location. So we'll put in the correct credentials, and hopefully the API route on the school Wi-Fi will cooperate. So as you can see, we've only put 4 images in the rotation, so let's maybe make that like 8, so we can see more images per cycle. And let's make the speed like 2 seconds, so that we just see a bunch of images real quick. Once you hit update, the page automatically refreshes, and you can see the images are going to cycle by a little bit quicker, and there will be more images in this set than there were a few seconds ago. So the ability to customize your mural is as instant as, or as quick as you can put the settings in. That's a majority of our demo, so I'm going to waltz back over to the podium and give the rest of the presentation. Yeah, I know how to do that one now. Let's see, can I get presenter view back? Hey! Okay, so there's a lot of technology that we had to use to get this working. At the forefront is Next.js, which is a full stack solution that incorporates both a back-end service and a front-end service. The front end uses React, a term you will no doubt be hearing a lot of throughout the senior presentations. It is a wildly popular JavaScript framework that's its core selling point is that it allows you to create reusable components, HTML components using JavaScript. We took a step further and actually used TypeScript for our project so that the data models that we wrote for communicating between the backend and front-end layer were consistent. Our client asked us to use a library called GeoFireX for querying geographical data. So like that's how we take the user's location and query it against the database. We use a lot of Google services for this application, mostly for compatibility with the existing architecture. Google Maps for the big old map. But a lot of our backend functionality is handled by Firebase, which is a Google app development platform that provides a lot of different tools. The ones that we used are Firestore, which is a NoSQL database. If you've used or heard of MongoDB, it's just like that. And Firebase Auth for the logging in and user credential check. All of our deliveries are Dockerized. They're containerized using Docker. And one big selling point of this is that if the client needs to choose different API keys or whatever, they don't need to rebuild from source. It just is environment information going into the container. Before every build, we have unit testing, automated unit test suites that we wrote using Jest and React testing library. For code, for source code management, we use GitHub. For team management, we use Jira and Confluence, part of the Atlassian suite. And for team communications, we use Slack. So when going through all of the different interactions that we have in our app, we took a look at it from a user's perspective and broke that down into the components that the user would interact with. Going back to React and components, this is its core strong suit. We were able to then, once breaking down the functionality into components, we can compose pages by linking these components together. And in this time, we would use the data models in TypeScript to create some mock data to flesh out most of the front-end functionality while our APIs were developed in parallel by John. John did most of our back-end programming. Once the APIs and the front ends were ready to talk to one another, the mock data was substituted out for an API call, and all that we had to do left was to just polish and make sure that the connection was good. So an example of how components are reused is in how we display images. It's a pretty simple example, but I think it shows the power of being able to reuse components quickly. So in that gallery grid on the sidebar, we created a component called the image tile, which loads an image from a remote resource and displays it with rounded corners and a box shadow. This image tile actually uses another component called the image with fallback, which is where if a URL to an image no longer exists, it will fall back to a secondary image. This is exactly why we used it for the user profile pictures. You can imagine they upload a profile picture and delete it. Now we don't have access to that resource anymore, so it will fall back to a default user profile picture. I bring this up because both of these components are at the same level in the HTML tree. So even though one depends on the other, you can still use components basically wherever you want on the website. Our APIs, as I mentioned, are a separate layer from the front end. So the backend secrets are completely safe from the front end. The backend layer has been designed to be RESTful, so our front end will make HTTP GET requests, or in the case of the display property editing, it makes a patch request. And the backend will do its best to convert as much data as it can from the database into the format that the front end needs, so that the front end can focus solely on displaying the content, which is already a hard enough task as it is. We don't want to have the formatting data and all that. The secure layer, as I mentioned, keeps our database separate from the front end as well, so we don't need to worry about users manipulating any of the data in ways that we don't expect. So the three image carousel was the main display mode that we went for with our client, but in the development of the app, they asked for more customizability, and so we've expanded this into two similar but distinct systems that you can use to implement different display modes. Unfortunately, we weren't able to get an example of the stream system for a live demo, but there is a video demo that we'll get into later. So the fetch display mode is the hallmark example for the carousel. It fetches a subset of the data in the database. As I mentioned, for the cities like New York City, you would not want to be fetching thousands and thousands of images all at once. So it fetches that small subset and gives the front end the information that it needs. The front end would then display this information serially, one after another, like the carousel or maybe like a sliding ribbon. And once that list is nearing the end is when it can call a function to refetch the data that our system provides. The refetch function automatically replaces any old content with new content, and that means that there's almost no implementation details on like fetching the data for the front end, so all you need to do is just deal with the data that you've been given. The stream mode is similar, but it is fundamentally different in that it hooks directly into the Firestore database using a Google connection layer. What that does is it alerts the front end anytime there is a new post to the database. And it would show that content right then as it arrives. So as I mentioned before, the stream system is implemented in the code base ready for delivery. And I have a demo of a prototype that our client suggested to us, which is called Bubbles. And don't worry, Pat, in our documentation that we're giving to you is the code on how to implement this exact demo. So you'll be ready there. So in this example, we created a small simulate post button that calls the exact same dummy API route that we called in our demo earlier to post a new picture. And you can see as soon as the data is received in the Firebase, the front end is alerted and a new image appears and floats to the top. This is just a really simple example to showcase that images and content can be received in real time. And you'll also notice that in this example, we are reusing the exact same components from the carousel component. So rapid prototyping is also available for this project. So the big deal there is that the Bubbles implementation only took 5 minutes to write, and the native carousel implementation without comments and all that is only 50 lines. So it's really easy to implement new and custom display modes after we're done with the project. We want to make it as easy as possible so that new and interesting ways to interact with this content could be achieved. One example is like a leaderboard. Since Stream can get information in real time, it could keep an internal cache of who has posted what, and you could have like a ranking leaderboard of how many posts went into the mural. We also could have custom animations or interactions with the content. It's really, the sky is the limit with the systems that we've implemented. And so with that, that concludes our presentation. I'm more than happy to answer any questions that you have. Thank you. Like Pat has a question. Do you need this? I think it's off. It's not just me. Hey.
First off, great job, guys.
Thank you.
Love the presentation. So how did you feel the existing infrastructure affected your development cycle? Because I know that sometimes working with legacy code base is something that we're going to experience throughout our development career. So how do you feel that affected you instead of working on something from scratch?
In my experience, it was actually pretty nice having a known data set to work with and to base the models off of. To be honest, it was more comfortable working with the fields that were provided in that original document than with the display properties, which was something that we kind of came up with mid-development. So I would say that the overall process was that we felt comfortable using the existing architecture.
Any other questions?
Right.
Seems to me you had a lot of fun.
Yeah, we did.
This project. Now you can actually hear me. So besides having a lot of fun, I'm interested in what your delivery package to your customer looked like. I mean, clearly you have a prototype implementation.
Yep.
You have a set of briefing slides that talks about how you went about doing business. Was there anything else? Was there a set of user documentation? Was there design decision documentation? Anything else that your customer's going to really like?
Yes, so throughout the senior design project, we had to make a bunch of documents, like a vision document, a software requirements document. All of those will be delivered. But we also have a lot of user documentation on how to work with the systems that we've created. As I kind of jokingly mentioned, we do have examples of how to implement those display methods that we created. And there's also documentation of what environment variables they'll need to pass to the container, what they do, and where they're used. So there is extensive documentation that we're providing so that hopefully it will be as seamless as possible for them to deploy.
That's very good, thank you.
Thank you.
All right,
So-
thank you, Eric.
Thank you.